Okay, and the final two functions that we're going to look at today in this series of 3 videos are the exponential function f of x equals 2 to the x and the sinusoidal function f of x equals sine x. So let's start with the exponential function. Now I'll just let you know, later in the course we will be doing an entire unit on exponential and logarithmic functions. At that time, we will review function laws and rules, and so we're not going to worry too much right now about using exponential laws to get the results of our function when we substitute the x values in. It is sufficient to get the idea of the picture. Just use your calculator if you must for this exercise. Okay, so let's choose some values of x. We're going to choose some negative and some positive just to see what happens. And again, like I said, if you're not sure how the exponent laws work at this time, that's okay. It's important to review them. We will be doing a more in-depth analysis of those later on in the course. So for now, if you need to use your calculator just as a review, that's fine. So let's substitute that negative 3 in for f of x. Or in for x, so we have f at negative 3 would be 2 to the exponent negative 3. And on your calculator, look for the y to the x button or x to the y, 2 y to the x, negative 3. And that is 0.125, or 1/8. So similarly, we would do 2 to each of the x values. 2, the exponent negative 2 is 0.25 or 1/4. I'm just going to put in brackets and maybe you'll see the pattern. 2 to the negative 1 is 0.5. which is 1/2. Now 2 to the 0, there is an exponent law that tells us any value as a base raised to the 0 exponent has a value of 1. So anything raised to the 0 is 1. And 2 to the exponent 1, that's just 2. 2 to the exponent 2 is 2 times 2, which is 4. 2 to the exponent 3 is 2 times 2 times 2, which is 8. So let's see what this looks like when we plot our graph. So negative 3 is 1/8, very close to the x-axis. They're hard to get it precise. At negative 2, it would be 1/4. Negative 1 is 1/2. 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. So you can see that on the left side of the graph, the curve is very, very close to the x-axis. Almost looks like it's on the x-axis, but it isn't. It's approaching it, but not quite touching. So we do have an asymptote on the left side of the graph here. Then the curve goes upward, and it becomes very steep very quickly. So this is our exponential function. Basic one is f of x equals 2 to the x. Let's look at the sinusoidal function. For this one, we're going to need a somewhat different type of table of values. When we're taking sine of x, x will be an angle. And in grade 11, you learned to write those angles in degrees. In this course, we're going to be using degrees and we'll be introducing a new unit called radians. But for now, let's stick to degrees. We don't want to count by ones because that would take us a very long time to see the shape of the graph. So we're going to count in 30-degree increments in our table. Now you can actually take sine of a negative number or a positive number, it doesn't matter, but just to get an idea of the shape of the graph, we're going to just do sine of positive values just to remind you of the shape and what it looks like. So we will start with 0, keeping in mind that these x values are actually in degrees. Then we'll count up by 30s. So 30, 60, 90, 120, 150, 180. And you should continue. Don't stop there. Keep going. So with a bit of luck, I haven't missed any. So now if you need to use your calculator to get these values for now, that's okay. It is going to be reviewed later in the course, and in the meantime you may want to review the notes you took in grade 11 on sine functions to see how to get these values using special triangles or using the unit circle. Okay, so 0 would be sine of 0. Make sure your calculator is set to degrees. Remember to check here, and you can figure it on your calculator how to change that if it's not. So we just find sine of 0. Oops. Sine of 0 is 0. Sine of 30, let's see what it tells us here. Big mystery. 0.5. Sine of 60, 0.866, and sine of 90 is 1. Now, you continue on your calculator if you need to, or just continue the pattern if you know it. I happen to remember it. I'm just going to go on. Here we go. Okay, so there's our table of values. And this is a periodic function. So what we really have done here is the table of values for one period of sine x. And we'll plot that and see what it looks like. Notice my scale on my graph. I've done 3 squares to 90. So I'm really counting by our 30 degrees, 30, 60, 90, and so on. It is not necessary to label every single square, but when you are counting by something other than 1, you should put what the values are on your axes. You should label your axes with the numbers. So also I want you to notice my y-axis. I'm not counting each square as 1, I'm counting by 0.5. So I'm taking 2 squares to get to a unit. So I'm just going to go ahead and plot while you do yours. So there's one period plotted, and it's going to just connect in a nice smooth curve. Try to avoid kind of a V shape. We want it nice and smooth. And we can continue that same exact pattern until we run out of room on our grid. I could even go negative if I had a little bit more room there. Okay, I believe on your handout you have more space. You could do some negative values and some positive values. So that is the basic function f of x equals sine x. Thank you for watching.